Right. Good morning, everybody. Good morning, everybody. Right. Okay. So you're starting 2028 A level. Most of you all are very energetic and probably want to do it very well. Have so many dreams connected to your brothers, your teams of the people who have done well. So you have a small vision of where you want to go to, which is all good. Okay? It's all very, very good. But I'll just give you a basic introduction first before we start work. Today itself we'll be starting physics work. Come in, girls. Have room. So I'll give a basic overview of the subject. So these A-level physics. What we will actually learn in our syllabus, our scope. Now, physics is a huge subject, very deep subject. It's a very evolving subject. And in terms of research also, so far, there's loads of research being done. And new things have been found continuously even now. So it's a very changing, dynamic subject. But your A-level exam has a particular scope. So you need to understand the frame. Say you are playing football. You play football, there's a court to play the football. Yeah. That court space is there. Same way in A levels also, there is a region where they will ask you for your A level exam. That region you should know well. There. That region you should know well now. In A level physics, local A levels, we talk about conceptual physics. This is how our paper is going to be made. Conceptual physics, you can call it logical physics as well. Logical physics as well. Your paper is mainly based on logic, scientific deduction, logic. There will be less calculation actually. I'll give a simple example now. Last year, 2025 A level, results are still to come. Maybe in 2 months results will come. The MCQ paper out of 50 had less than 10 questions for calculation. Everything else was select the correct answer, true or false answer. Yeah. So normally calculations are easy, but when it comes to selecting the correct answer out of 5 similar answers, that's going to be difficult. You should know your concepts very well. Understand? Know your concepts very well. So your A-level physics is based on this conceptual part. This is something that you should understand. Now your parents might think you solve a lot of problems. You can do very well in physics. So that is those days physics. Those days means that your parents are doing A-level. Now you are doing a new syllabus. Yeah. In this new syllabus, there is no doing a lot of questions. Is understanding the concepts very well. It is based on concept. Understood? Yeah. So if there is an idea that you have to solve a lot of questions, if I solve one type of question 100 times, I become better at it. That is all olden day talk. That's not the way it works. Because you're doing a new syllabus that your all of your education reforms are coming. Reforms are coming in 2030, so they are building up there. So therefore, everything is going to be based on concepts. Concepts you should learn very carefully with logical deductive knowledge. Don't just memorize. Just because you memorize, you can't pass A-level exam. That is something I want to tell you. Do not memorize. You need to understand. Memorizing and understanding are two different. Yeah. So you need to understand the concept very well. If you understand the concept very well, then you can apply it for anything and get the required what you call final conclusion and so on. Okay. So remember, in these 2 years or 2.5 years, the exam is going to be in 2028. Yeah. August. You are in 2026, March. So you have exactly 2 years, April, May, June, July, 2 years and 4 months. Right? 2 years and 4 months means 28 months for your exam. For these 28 months, there is a lot of work in terms of three subjects. Lot of work in terms of three subjects. So you need to actually, my advice to you is these 28 months while enjoying your school life. Do all of that, that is be done. You must give 100% focus to what you're doing here. Because generally what happens in most of the A-level students is the grade 12 work only they mess up. When they miss the grade 12 work, difficult to what convert to and do grade 13 work. I'll show in a while. I'll show in a while how important grade 12 work is. So first of all, remember, your A-level exam is based on what? What do you call this? Concepts. We'll be learning new concepts. Some things you might have had wrong, what you call, understand. Those things you'll be correcting it as you go along. Sometimes we have beliefs. I give a simple belief. Have you seen when people buy a new vehicle, they hang three lime and one chili, right? Tell me now, you tell. Why do they hang three, what you call, lime and one chili? For protection, they believe that the three Dehigedi and one chili will protect them. Now, Toyota company, Toyota, Jaguar, whatever you want, they send the vehicle through rigorous testing process. They have crash testing, this, that, everything. And then only they send the vehicle to Sri Lanka, whoever buys it. But the first thing they do is they hang what three, what you call, lime and one chili and say what? Now the vehicle is protected. Tell me now, is that logic or belief? Belief. Nothing wrong in three Dehigedi and one chili. But will it protect the vehicle from accident? I don't know. In that case, all vehicles with three Dehigedi and one chili will not but come into an accident. That means when the vehicle is coming with three Dehigedi and one chili, the other vehicle will go around it. Nothing will happen. That doesn't take place. No? One is a belief, one is what? So two different. Then, so I suggest all of you all to keep your beliefs to yourself. Logically learn the subject. Beliefs should be there, otherwise the civilizations can't go forward. That is part of anthropology. What you call having fasting period. Very important. With Catholics are having late season. Buddhists will have what you call the and all of that. Those are important things for as a society, as a cultural cohesion to move forward. Yeah. But in generally, when it comes to sciences, there is a way of deductive thinking. That deductive thinking you have to clear. So some of you all had beliefs, good, keep those beliefs. Sometimes you might think, okay, for example, if I ask you, why is the what you call Bermuda Triangle? If I ask you, why do ships sink in the Bermuda Triangle? You all know about the Bermuda Triangle? I heard. Why do ships sink? Tell, tell. Have you all heard about the Bermuda Triangle? Yes or no? Where is the Bermuda Triangle? Which okay? Which country is it close to? USA. Bermuda Island, USA, and some other point, all three together. You have the Bermuda Triangle. Ships and all sink when they go into the Bermuda Triangle. They sink. Why? What are the stories that you have heard? Aliens are there. One story is alien. Guaranteed. Huh? One story is aliens are there. They are waiting. It's good. Baka tell what? Take it. Yes. What else? There is some evil activity taking place there. So therefore, if you go there, Our things will pull the tip down. So that's the scientific reason. Yeah. There is one reason is strong electromagnetic. Is the main reason. In that region, you have underwater volcano. Therefore, a lot of sulfur is there in the water. When sulfur is there in the water, the density of water has reduced. So when a ship goes, there is no way to balance the upthrust, it will go in. Then they say, that's a ship. No. What about the planes that go in? When sulfur goes into air, and when sulfur goes into the engine, what you call turbos, what happens? It will start, what? Stop rotating. Yeah. Then what happens? Difficult to maneuver. That's the truth. But what do people like? They like the story or they like the truth? They always like the story. The stories are meant to be stories. Huh? Logic is always meant to be what? Logic. Sometimes you yourself might know the truth. You can go and tell everybody at home the story. They will believe what? So, yeah. So knowing the logic truth and then telling the story, you can tell the story much more what? Better. If you don't know the truth, then the story was you're not sure no. Against the Sri Lankan politicians, they know the truth. They can tell the story very well. So I think science students should learn something from the politicians. You should know the truth. But then know how what to tell the story also very, that's part of your ability. Communication ability. Okay, it's pretty helpful. Right. Anyway. So remember, is conceptual physics that you're learning. Now, there is something called mathematical physics as well. Mathematical physics. Mathematical physics is our physics. Huh? Conceptual physics. This mathematical physics is there in our neighboring country. Who? India. There they do mathematical physics. And in Sri Lanka, most of the books are here. Indian books are here. Some people go and buy Indian books and they think, okay, physics source is like this. Our physics is a different physics. Not mathematical. In your A-level syllabus, the maths needed is only what? Subtraction, multiplication, what? Division. And you will need a bit of what? Indices. No, indices. Indices. And then logbook for that, but let's say logbook has logbook has. That's all you need, huh? You won't need integration, differentiation, calculus, all of that is there. Not needed. Therefore, don't over pressurize yourself with things that are not important. And open. All you for A level. If you learn physics in detail, let's say you do a master or let's say a PhD someday, yes, then it goes to that range. Clear? But not in A level. Like in A level, we have bio students doing A level. We have math students who are doing A level. There are some students who take this as a common subject. Have to do IT. They also take what? Therefore, remember, what we have is conceptual. So do not worry about the mathematics. But mathematics is important. That's the language of science. Yes. So you will need to brush up with your but plus, minus, multiplication, division, indices, logs, also factors, common factors, factorization. In grade 11 work, quadratic equation, x squared plus 2x plus 1 equals 0, how to factorize all of that. So that will be the hardest. Actually, the hardest will be the quadratic part. X is equal to minus b plus or minus square root b squared minus 4ac divided by 2a. That's the only hardest equation which you'll have to use. You already learned in grade 11. I think grade 11 book is there. Therefore, do not worry about the mathematics. So the first thing, especially the bio students think up, there'll be a lot of mathematics here. That's all. So therefore, very easily you can cope with it. Very easily you can adjust. Do not worry about the subject. So my attempt in the first half itself, just to tell you all that what you think about physics and what physics actually is are two different. So far, maybe you have a small idea about physics, mainly based on what your O-level teacher taught or your school teacher taught or whatever. Yeah. When A-levels will be starting from the very beginning itself, from the basic. You will start learning from the basic, from the building blocks of physics. So nothing is everything you learned in O-levels, again in A-levels will be learning those. So therefore, there is nothing for you to what? Worry. So do not worry and over-pressurize yourself. Like I said, now the mathematics belief is very simple work here. But remember, you'll be learning a lot of new concepts if you are not learning. Make it practice. The reason why you might find physics difficult later is if you lack practice. You don't go and look at your work at home. That is because of you. I told you, this is a project that you must do very carefully for 28 months. Every week, every day, you should at least look at your book for what? In the beginning itself, at least half an hour look. Whatever work done, because work is going to be done. I don't know about other classes, they might tell stories and wait, but I will of course start learning. Because we have a huge syllabus to finish. I must finish that also in the stipulated time, keeping about 4 months for your revision. So 2028 March, your work will be done and finished. So you have required 4 months to get ready and do whatever work that you have to do. So therefore, remember, one is conceptual, so that is good enough there. Now, in your A-level physics, you have 11 lessons. Grade 12, you have 4 lessons. Grade 13, you have 7 lessons. You might want to write the balance. You could have balance this 5 and 6 and 5. I'll tell you the reason why. Your grade 12 work is the most important. You will be learning mechanics. That is the heart of physics. Without your heart, you're dead. Same way without mechanics, physics is dead. Your motion is dead. You can't even sit there. Then comes waves. Then we learn about optics, light. Light. And then you have thermal physics. This is called classical physics. Huh? This is called classical physics. Very important. This is your complete foundation. Everything that you need to know about physics is there. You might wonder, sir, then what is the grade 13, 7th section? Grade 13, that is your applications of it. Whatever you learn here, the applications are there. Here you will have gravitational field. Gravitational field. Then you have electric field. Then you have magnetic field. Then you have electricity. Electricity. Then you have electronics. Then you have properties of matter. And then you have matter radiation. Matter radiation. 7. 1, 2, 3, 4, 5, 6, 7. Look. Gravitational field, application of mechanics. but in a field concept. Electric field applications of mechanics and waves. Magnetic field application of mechanics and waves. Electricity application of electric field. Electronics, because you have electricity, that's the divisor. Electronic. Properties of matter, again application of mechanics. Matter radiation, application of thermal. You see how they have structured the A-level syllabus. Grade 12 is very important. Without grade 12, you can't do grade 13. Grade 12 is your foundation. Whatever you need to know is there. Then comes grade 13. From grade 13, what? Everything is application. So they expect you to know your grade 12 very, very. If you know your grade 12 very well, grade 13 is going to be a very nice, smooth walk in the park. So then you'll be interested in applications, all of that. So it's going to be very, very interesting. But if you are not good in your grade 12 work, if you play the pool in grade 12, you don't do your homework, if you like A-level, O-level, O-level, most of you are studying in the last 2 months only, and you'll whatever results you'll get. A-levels, you can't do like that. Okay. Right now, I think every class you went to that told the same story. Therefore, I don't need to expect, tell you all more. So I'll give you a basic idea. So grade 12, you have 4 subjects, 4 sections. Grade 13, you have what? 7 sections to cover. These are simple. This is very, very good. So now you have known the structure of the A-level syllabus. Don't write all of this. You can download from NIE website. Okay. Now just look. About your A-level paper. A-level physics paper. Paper number 1, 50 MCQs. Paper number 1, 50 MCQs will be there. Every MCQ 1 mark. 1 into 50 will be 50 marks there. So there is a chance for you to get 50 marks there. Okay. Then comes paper number 2. Paper number 2 has 2 forms, structured essay and essay paper. Structured essay, you have 4 questions to do, compulsory. Each question 20 marks, 80 marks. Essay, question number 5, 6, 7, 8, 9A, 9B, 10A, 10B. Out of 6 questions, you must do 4. Selection. 4 questions, 30 marks each, 120 marks. So 120, 80, how much? Total 200. From that 200, they'll take for how much? 50 already given here. So out of 200, whatever marks you get, that they multiply for 50 and they get it for what? 50. So let's say you get 100 marks out of 200, and out of 50, you'll be getting how much? 25. So what they do is that. So remember, these are your A-level physics paper structure. The basic idea. Also, in terms of these, you will have practical. Now, in your syllabus, they have removed the mercury practical. So generally, those days, of course, there was 42. Also, in the NIE website, you have your practical resource book that you can download. You can download it. Then all the required practicals are there in detail. They have to we'll be doing in class as well. So therefore, there is no problem. All the resources are now there in the NIE website. You can download it from the NIE website, including the system. Those days you had 42 practicals. Those 42 practicals, certain mercury practicals have been removed. So those mercury practicals are there mainly in thermal physics. So generally, you have about 35 practicals which are done in class. The mercury practicals are removed. Majority of the practicals are based in these sections. Practical here, practical there, practical there, practicals are here, practicals are there in electricity, practicals are there in properties of matter. Loads of practical sections. You can see. So these are conceptual, but practicals are there here. There are certain electronic practicals as well, but we'll do those electronic practicals. But in your schools, most probably they won't do it because there's something called the Maggie board. Have you heard the Maggie board? Anybody has done electronics in O levels? You all know there's a separate subject called electronics O level. Anybody has done? You're done. There's a Maggie board. The Maggie board only you can set up the circuit. That's not the Maggie that you eat. Huh? Not the Maggie board. The white color board with small dots. You have series and you have parallel dots. Yeah. That's how you connect the circuit. Those Maggie boards are not given to all schools. Therefore, the requirement for the practical is what? Very less because the boards are not given. Actually, every student should have at least one board. Not manipulate. Therefore, still they have not given it. Most probably for all, but if education reforms are done, everybody will get a Maggie board and they have to do all of it. But technically, up to now, they have not given electronics questions for your practical. That's mainly because the resources are not given to the school. There. But generally, in the class, we will be teaching all of those. Okay. So there you go. So you know that A levels is about conceptual physics, A level, local A levels, or A level. Grade 12, you have 4 sections. Grade 13, you have 7 sections. Altogether, 11 lessons. Practicals, there are about 35 practicals, excluding the mercury practicals and the electronic practicals, which you will not get for your paper. The practical sections I have put here in this. You can see loads of practicals in grade 12. So if you are going to school, if you are a school student, you will have practical sessions in school. Please go and do those practical sessions. Are very important. Don't go and play the fool in the practical class. One fellow will do, the other fellows will look up and wait, and then copy on that fellow and wait. Make sure you are involved in the practical process because it's very important because they'll ask. Now your structured essay is not on process. Those days structured essays people memorized and wrote. Now you can't. They'll ask where things go wrong. Where things go wrong because I'm doing my MSc 6 in University of Colombo. I know this because most of the lecturers who make the paper, they teach us in research. What you call and what they tell you. He asks exactly where things go wrong. Where things go what? Wrong. So how do you know where things go wrong? Only if you do the practical alone. Clear? Then only you understand where things actually go wrong because that's what they want to do. They want to give you a practical, not to get a nice answer. They want for you to do the practical so to understand where things can go wrong, how well you can modify this practical. How well you can what? Modify the practical. Because modification of the practicals also are what? So make sure guaranteed if you're trying to become a private candidate, my advice to you is don't. At least try to find a very small school which has A levels and which has a 6 lab, chemistry lab, bio lab. Go and study there. Not actually A levels doesn't depend on how big the school you go to. Only important thing is you have the minimum resources to what? If that is there, the rest is all you. If you decide to do this very well, guaranteed you will do it well. So whatever, that's why now if you take Sri Lanka, fellows from Royal College also go to university. Fellows from Horopatana Central also go to what? Fellows from Trinity College also will go to university. Fellows from a very small Madhyama Vidyalaya also will go to what? Important thing is you. School is good for your prestige. Tell someday I'm old boy of this school, old girl of this. That is when you're putting your children to school, you tell. Doing your A levels is not important. That is all you. Understood? So if you are trying to become a private candidate, number one, 2 things. You will stay at home and become late. When you are lazy, a lazy mind is not good for a scientific brain. You should be busy every day. You should be tired every day. When you put your head on the pillow at night, you fall asleep like this. You can't be looking at the ceiling and saying, that means you're late. And those who actually work, when they keep their head on the pillow, 10 seconds gone. Fellows who look at the ceiling, think what's going to happen is that those fellows are late. Their mind is what? not tired. So mind is not tired, the mind is working. They are off the light in the room because what the people in the home have off the light in the room. Otherwise, they'll keep the light on and wait like owls. Hello, owls at night. Yes. Therefore, remember, number one, a science student should be very tired at the very end of the day, not because of not doing anything else. Why? Because what? They have worked very hard. And remember, science means something I'll tell you all. You won't be a very happy, but if you want to do science because you want to be happy, you stop doing it now. You want to be happy. My advice is join a circle. Tell ice cream. You will be happy. If you're doing science, you won't be happy. Why? Every day, something new. Every day, you have to grind the hours through to get that concept correct, to get it right. First time you do, you'll get it wrong. Second time you do, you get it wrong. Third time wrong. Remember, Thomas Alva Edison, whatever amount of time, he got the same thing wrong. Keep persistence is very important. You'll be learning new things. At once, you won't grasp it. Then don't give up. To have the self-discipline to go home, take time. Enough and more resources are there. Using those resources, you should be able to what? Somehow learn it. Somehow get the concept correct. Somehow get the problem what? That, what do you call it? That motivation should be there every day. Recently, I watched a small video on what you call here teeth main product questions. I was telling because motivation is temper. Discipline is what? Motivation is what? Temper. People can motivate you, but it's going to be temporary. Your discipline only is what? Yeah. I think that is very important. You can be very successful in whatever you do. Motivation is the people who motivate you today, sometimes next tomorrow they'll start scolding you as well. Motivation is temper. Discipline is what? Very firm. Uh, right. So there you go. That is in terms of your basic work that you have for A level. So remember, it is not a difficult thing to do. You have to have a amount of personal. Okay. In terms of our A level program, what we are going to do. Number one, we should have a CR book for theory. We should have a CR book for theory. And remember, in the theory book, do not solve problems. I don't like that. Some people write theory, then do questions. Theory book should be what? Theory book, like a nice story to continue. For that, have another CR book to do what? Questions and tute work, etc. Tute work. So every day when you come, you should have these two books. One is your theory book, one is your what? Yeah. One is your theory book, one is the question book. In the theory book, do not do question. Reason being that loads of questions will be done. Loads of questions will be done. And the question will hinder your studying process in theory. So make sure you study the theory in order. And whenever we are doing questions, you can write present in your theory book. You are writing the theory, then question number 1 to 15. Then you know to turn back to your question book, 1 to 15 will be there. So someday it's easy for you to find the questions as well. The question book is there separately in order. You can number it 1, 2, 3, 4 like that. Now exam batch, this year exam batch, I think normally they'll have about 14 PR books. Here. Question books will be more. Good here. Coming. Oh, So, therefore, remember, we have about 14 theory books and even more number of questions, 20, 25, whatever. 22 more questions are there. So make sure you bring these two books minimum for your work. What is there in your tute? Remember, in your tute, new questions will be there. Apart from that, all past paper questions will be there. All past paper questions from 1980, whatever relevant. 1980, now you all are doing 2025, we've done. All these questions will be there. Okay. So therefore, everything is there in your tute. Yeah. Everything is there in your tute. So there is nothing that you have to what? Worry. So tute questions are there. Yeah. Tute questions are there. Make sure you do it well. What happens is this after your first year, after you finish mechanics, after mechanics, so for the ones who can't remember here, you have to finish mechanics. We'll be starting the paper class. Paper class will start. Paper class and revision. Paper class and revision will start because then only the work starts a lot, you start forgetting. Yeah. So after mechanics is over, and this is over, the huge section, once this is over, the paper class will, so parallelly on a different day, of course, paper class will happen. Theory class will be on Sunday. Paper class will be on a different day. I'll let you all know as we develop. Okay, no? So that's the program. So generally, this revision and paper class will continue until your exam. Now, if you take this year batch, I will talk about last year batch, 2025, they did about 60 full papers before they went for the exam. 60 full papers. This year, fellows will do even more than that. You will do even more than that. So generally, around more than 60 papers will be done for you. That's model paper. Huh? There. Past papers are already here. Past papers are done in class. These are model papers. These are model. Understood? Clear? So, past paper, there is no separate class. Past paper should be taught is a theory class. Clear? When you learn something, you should know how to solve a past paper question. If you can't solve a past paper question, that means that you don't know what you're doing. That is done in the theory class. These are model questions. Clear? These are model questions. The separate program altogether is there in your theory class itself. So in your tute, these things will be there. These things will be there. Okay. No? So I think too much talk was a one day. These are the things that we'll be having, and don't think too much about it. I've been doing this for 18 years and producing results every year. Therefore, that's normal for us, natural for us. For you all, it's a huge goal. Try to get into the normal process, it becomes very normal. The important thing from your part is be disciplined. I hate indiscipline. 2023 back, more than 40 boys I chased out of class one day because they didn't do home. Don't put it to that level. Boy or girl, if you don't do homework, I'll chase you home. You might ask me, sir, that's me. I can't change me. No. My work process is that. If I give homework, I expect you to honor that work. Clear? Because if my work, if I'm doing perfectly, I expect your work was to what? To try to achieve perfect. Why? I'm teaching future professionals. When I'm teaching future professionals here, I require a certain amount of what? Professional ethics. Some of you all will end up being doctors. Okay. Now, for example, now this year, the bio parents are one of my students. Okay. Now she will be starting bio. You can ask and see from there is a certain amount of discipline because they are professionals. Someday they will become doctor. There is a professionalism involved in that. There is a certain amount of work ethic involved. I expect that. Expect that from now on. Because I'm now not teaching A-level students. I'm teaching future professionals. That's how I see it. I don't know how you see yourself. I hope you start seeing yourself like that. I hope you start seeing yourself like it's not some person living in some village, somebody's time. I'm teaching a future, but professional. I require you to see yourself also like that every day morning. Look at the mirror, see professional. You need to see that. If you don't see that, you will never see your future properly. Huh? You need to see yourself first as a professional. Then only you will become one. If you don't imagine in your head and work towards, let's say, becoming a doctor or whatever, you will never see it. You will never have it. Will happen. It won't happen. If you want to do your, let's say, you want to be a professor, PhD, whatever, you must see yourself in that level. Otherwise, you won't what? Remember, whatever you build is first start built in your what? Head. You don't build it in your head, nobody's going to build it for you. Understood? You need to first build that in your what? Remember, I'm teaching professionals. I require professionalism. So I don't really care about how many students are credit class. You don't follow my process. I will chase you home. I will not mollycoddle you, Ane Baba, hello Puta. No, that talk won't come from me. Understood? Yeah. Someday when you work, let's say doctors, you work under what you call consultant check and see. He will say, Ane Puta and wait. You will get scolded properly. Don't do the job properly. Engineer someday check and see your consultant. They won't just mollycoddle you. If you get the thing wrong, you will get scolded. You have to work normally, generally engineers, they will work 16, 18 hours. Same kit, same dress. You have 6 hours sleep here and there. Again, next day morning, same process start. Therefore, remember, the process is going to become a professional is difficult. Once you become a professional, then much get much more what yeah. Therefore, remember now, when here, what you call, one of my old work, architect, they do huge project. He worked in what you call Colombo City Center project, a Port City project. Huge project, right? They have to be professional in whatever they do. Otherwise, you can't keep that required. Yeah. First, see yourself as a professional. Then everything will fall in line. If you are a professional, then what? Today you should have a diary or a book. What is to be done today? Your work requirements should be put. You call that a work list. Understood? Professionals have work lists. Fellows who just wait don't have anything. Today morning they'll get up and say, what is there to do today? Professionals, tomorrow morning, what you need, they have written and kept. Whenever the work is done, they will tick whatever they could not do because you're human. That is put for the next day. And that is somehow finished first itself. That level is it. If you have that level, guaranteed you will be a success wherever you go in that. Yes. You might do science and end up becoming a baker. You become a very good baker. Scientific baking. Actually, a lot of science is there in the kitchen. Most of you all go to the kitchen to eat and wash your hand. A lot of science is there. If you properly do it, it's going to be something marvelous. A lot of chemistry is there. Huh? Your grandmother mixes what you call apple and all of that. She does it. There is no science behind it. That's like the taste. That old woman doesn't know that she's doing science. There is a science there. Understood? And nowadays we watch and all how chefs work. They use instruments. When they cook meat, they put a thermometer, check and see what's the temperature inside the not outside. Those days your grandmothers by what you call taking a piece, tasting, they know whether it's properly cooked or now what? They fork and check and see whether the chicken has reached inside what temperature. Understood? Level has come. Okay. So I think enough said. We'll start work. The first lesson is mechanics. Under that main subtopic, units and dimensions. Right. Units and dimensions. Also, just before I forget, before your results come, until your results come, class will be from 8 to 11 on Sundays. After results, I think I saw yesterday in the papers that your results are coming in April. After results, your class will be from 8 to 12 with a break. 3-hour class, no break. 4-hour class, there will be a. Okay, no? Okay. So today, invariably, you have no break. Understood? Right. Okay, units and dimensions. Right topic? Units and dimensions. Online students, any doubt, you can answer. Right. Okay. Like I said, we start from basics. Now, physics is a science of measurement. We'll be measuring things. But what are we going to measure? Whatever that we can measure is called physical quantity. Clear? So whatever we can measure, we call them what? Physical quantity. Clear? Everything in physics that you will learn in this universe is based on 7 fundamental quantities. We call them fundamental quantities or basic quantities as well. So fundamental quantities, or we call it basic quantity. Fundamental quantities or basic quantities. There are 7 fundamental quantities. These 7 fundamental quantities are mass, length, time, thermodynamic temperature, electric current, right here, substance of matter, luminous intensity, mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Don't write, look. The units are, mass is measured in what? Kilogram. Length is measured in meters, time is measured in seconds, thermodynamic temperature in Kelvin, capital K. Don't write, look, I'll give you time to write. Electric current, amperes, you all know this from O level. Substance of matter, mole. I'm showing chemistry, all learn mole. And luminous intensity, the unit is called CD, candela. This one you will not learn in A level. That is therefore maybe university first, right, to do it. So these are your 7 fundamental quantities. Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Everything in this universe which is measurable is either you can make from this or combinations of these 7 fundamental quantities. That is why you call them fundamental quantities or what? Basic quantities. Clear? So whatever you can make using these what? 7. Yes, you can make using this. Imagine like the 7 most important ingredients. From these 7, any combination you can put together and make something else. Clear? So those are called what? Fundamental quantities. You know, fundamental quantity. We also call them basic quantity. Right. Let's put that is more sentence. Quantities that can be measurable. Quantities that can be measurable are known as physical quantities. Are known as physical quantities. Quantities that can be measurable are known as physical quantities. There are 7 fundamental quantities. There are 7 fundamental quantities. There are 7 fundamental quantities as indicated below. As indicated below. As indicated below. Write down. Also, any doubt, please ask. So far, so good. Okay. So 7 fundamental quantities. So if they say basic quantities or fundamental quantities, these are your quantities. Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. In your A levels, up to the 6 you will need. 7th one is not much needed. That of course you won't talk about it in A level. That you will talk about it maybe university first year if you do physics special or whatever you will talk about. Okay, okay no? Clear? Right? Now there are 2 supplementary quantities. Two supplementary quantity. What are your 2 supplementary quantities? Supplementary quantities are plane angle and solid angle. Plane angle is measured using radian. Plane angle is measured using radian. Solid angle is measured using steradian. Steradian. So there are 7 fundamental quantities and how many supplementary? 2 supplementary quantities. Your 2 supplementary quantities are what? Plane angle and solid angle. Yeah. Different objects get a shape because of angle. So for an object to get a shape, pose angle is important. That is why these 2 supplementary quantities are there. Plane angle and what? Solid. That's right. There are 2 supplementary quantities. They are that is, Right. Okay. Plane angle, solid angle. So you have 7 fundamental quantity and what 2 supplementary quantity. Now you have a small problem. Some of you are thinking, we didn't study radian. Angle in O levels, what you all learn? What angle? Degrees, no? This radian is new for you all. Remember, mathematically, we always measure angle using what? Radians. But there is a relationship between radians and degree. There is a relationship between radians and degree. Relationship between radians and degrees. This is your relationship. Huh? This is your relationship. Pi radians equals 180 degrees. Now, what is this pi? In O level, you all learn pi, no 2 pi r squared. The pi value is how much? 3.14 or 22 divided by. So pi radians equal 180 degrees. This is your relationship between degrees and radians. For example, somebody will ask to convert 10 degrees to radians. 10 degrees to radians. How do you convert? Easy. 180 degrees is pi radians. 1 degree is pi over 180 radians. 10 degrees is pi over 180 multiplied by how much? 10. That's pi over 18 radians. Understood? 10 toffee is 100 rupees. 1 toffee is how much? 5 toffee is how much? Basic. Clear? 180 degrees is pi radian. 1 degree is how many radians? 10 degrees how what? How many radians? Same way you can convert radians to degrees as well. For example, pi divided by, say, well, pi divided by 2 radians. How many degrees? Pi radians equals 180 degrees. O-level maths, your maths you would have taught. Whatever you do to the left hand side, you must do the same thing what to the right hand. So to get pi divided by 2, I must divide this by 2. So this side also I must divide by how much? So 180 over 2 is how much? 90. There you. Pi over 2 radians is 90. So this is your relationship between degrees and radians. Clear? That's right. Relationship between radians and degrees. Relationship between radians and degrees. Relationship between radians and degrees. Right now, pi radians equal 180 degrees. Okay, finished. So we'll do some questions on this, quick conversions. How to convert degrees to radians and radians to what? Degrees. So always remember the scientific method of measuring the angle is always what? Radians. All mathematical angles. Now, maths boys will learn, boys or girls will learn what you call terms of what you call trigonometry, calculus. All of that is based on what? Radians. Yeah. All scientific calculations in mathematics are based on what? Radians. Then finish. Anybody still writing? No? All good? So far, so good. We are just in the beginning. Huh? Introduction level. Okay. Right. Convert to radian. Convert to radian. Quickly do this. Convert to degree. Okay, work. Okay, done. Done. I'll give you 2 more minutes quickly. Finish it. The ones who are doing it. Good. Very good, Kalam. You're from Candy. Mother. Mother is a good school. Very good. Hold it. Once. Yeah. Everybody is Kalam. But will be after level first. Good. So I do the exam. So I from Kalam. Scores are very high. The chance is not there. Yeah, high. The chances are very high. Not there. Not of course, like, take it slow. Because they have important that case can be a bit. So, fellows can't get into medical second even if you get 3 years. Is like doing in your home town itself is very poor. So the advantage is that it's good. Right, okay. How do you convert? So 180 degrees is pi radian. 1 degree is pi over 180 radian. 15 degrees, how much? Pi over 118 into 15. That will give you pi over 12 radian. You got this corrected, huh? You got it corrected. 30 degrees, pi over 118 to 30, pi over 6 radian. 45 degrees, pi over 180 into 45, how much? Pi divided by 4 radians. 60 degrees, pi over 180 into 60, how much? Pi over 3 radians. 75 degrees, pi over 180 into 75. 15 times 5, 15 times 12. Pi divided by 12 radian. Pi divided by 12 radian. 90 degrees, pi over 180 into 90. How much? Pi divided by 2 radian. 120 degrees, pi over 120, 180 into 120. 2 pi over 3 radians. 135. Pi o 180 into 135. 3 pi o 4 radian. 150. Pi o 180 into 150. Pi divided by 6 radians. Pi divided by 6 radians. Then 225. Pi o 180 into 225. Pi divided by 4 radians. Pi divided by 4 radians. How many of you have got all of this correct? Others who have any corrections, quickly do it. Yeah. Online students, any doubt? Supplementary means additional units. They say you take supplementaries and you go to the gym. Additions. These are additions to the basic functions. Right. Okay. Anybody doing any corrections? Anybody doing any correction? Nobody? Right. Okay. I will solve that here. Pi radians, 180 degrees. They want pi divided by 3, 60 degrees. 2 over 3 pi. That means you multiply this by 2 over 3. 120. Pi radian 180. Divide by 6, divide by 6. How much? 30. Pi radian 180 degrees. Multiply by 5, divide by 6. Multiply by 5, divide by 6. How much? 150. Pi radian equals 180 degrees. Divide by 8, divide by 8. How much? 22.5 degrees. You got this? Then what? Pi radian equal 180. Multiply by 3 divided by 8. Multiply by 3 divided by 8. 22.5 multiplied by 3. 67.5 degrees. Do you get this? Good. Then multiply both sides by 5 divided by 8. 22.5. 22.5 multiplied by 8. What's your answer? Sorry. 0. 16 and 4. No. Multiply by 5. Right. And 12.5. 112.5. Then how much? Here, pi radian is 180. Divide both sides by 12. 15 degrees. This one. Pi radian 180 multiplied by 5 divided by 12 multiplied by 5 divided by 12. How much? 12 times 1, 5, 75 degrees. Pi o 180. Pi radian is 180, divide both sides by 18. Answer is 10 degrees. People who got this, put hands up. Anybody doing any corrections? Quickly do it. Huh? Right. Okay. So no issue. You can keep in decimal. Can, no issue. You can do it by head also, no problem. Right, somebody has asked, do we need to follow the same process? No. If you all can solve this in your head and put the answer directly also, no problem. But the ones who find it difficult, you can write the equation and get the answer. There is no rule like that. Okay. So there you go. So these are you convert radians to degrees as well as what degrees to radians. Okay. So you have 7 fundamental quantities, 2 supplementary quantities. You now know how to convert degrees to radians as well as what radians to degrees. Radians to degrees. Now there is a connection between this angle when it comes to a circle. There is a connection between these angles when it comes to a circle. Right? So anybody still writing this? No what? Look. Tell me, what does this look like? Size of feet. This is called arc length. S is called arc length. Radius, angle theta. Remember, theta is in radians. Theta in radians. There is a relation between arc length and theta. That is going to be S equals R theta. S equals R theta. Now look how the circle was made. Huh? Tell me now, if theta is 180, what is the shape? If theta is 180, what's the shape? Semicircle or half a circle. Very good. So it will be a circle like this. Semicircle. Angle about, normally take angle clockwise, here 180 degrees. So how do you substitute for this arc length? S equal R theta. Theta is 180, you must substitute radian. Radian means how much? Radian means how much? Quickly tell. 180 degrees is how many radians? Pi radian. So I'll put theta here. R pi. So this is familiar. Circumference of a circle is 2 pi r. Half a circle is 2 pi r divided by how much? 2. What's your answer? Pi r. Pi r. Clear? So actually, these are in O levels, they should teach the teach in A level. Mathematics, this is the connection. So it's equal RT. Now you tell me, if theta is 360 degrees, that means 2 pi radian. Huh? What's the shape you will get? Circle, full circle. Huh? Full circle you will get. Angle here 360 degrees or 2 pi radian. Arc length is going to be this outside arc length. Huh? S equals R theta. Theta is 2 pi. 2 pi r. Then what is 2 pi r? Circumference of the So you're getting those equations by this basic equation. S equals R. But theta you're substituting in what? Radian. That's all. Real? Right? Look. The arc length, the arc length, the arc length, and the angle are connected by the arc length, and the angle are connected by the following relationship. The arc length and the angle is connected by the following relationship. Right up. Then you can put both the examples as well. Huh? These are example. These are an example. These are an example. That's what the doubt asked. Okay. Right. Okay. Now look. Now there are different ways of learning physics. I'll teach you few new techniques that I'll be using in class. Yeah. We'll be using in class. One is simulation. Simulations is one. Yeah. More than saying and drawing. We'll do the basic things are done. Saying, drawing. Simulations also can be used. Yeah. Anybody still writing this? Quickly write. Simulations also done. So there are certain simulations which are developed or which are being developed now. Now, to take most of the research done, to take University of Colombo Department of Physics, there is research been done collaborating with the medical faculty in Colombo. They are developing new novel devices using what do you call flexible electronics. What do you mean by flexible electronics? Have you those days you all eat bubble gum? I don't know. In our time we had bubble gum. Inside the bubble gum there was a sticker, tattoo sticker. Superman is there, He-Man is there. So, you have different Batman is there. Have you all eaten bubble gums with stickers inside that you can paste it on your skin? University of Colombo, they are developing. Actually, now it's in what you call research state. They are trying to in the research state where a patient who is having, let's say now most of your family in Sri Lanka, the biggest problem is what's the silent killer? Future doctors tell what is the silent killer? Silent killer is not a murderer, not a horror story book. There is a silent killer that is there in your home. Think about your family and tell in your family this sickness is there among everybody, majority of huh? Diabetic is not very good. There is one more. One is diabetic, the other is high blood pressure. Very good. One occurs because of high intake of sugar. There's a research put out by what you call Ministry of Jayawardenapura Food and Nutrition. Average Sri Lankan takes 34 kilograms of sugar every year. Average Sri Lankan, that means you and me, myself separately. 34 kilograms of sugar. That is 3 times the WHO maximum intake. World Health Organization has given a criteria saying that for a year, maximum maybe 10, maximum maybe 10, I think less than that, very good. We are taking what? More than 3 times, 30%. So guaranteed what? Diabetic is there. Next is high pressure. High pressure reason is what? High salt intake. Your murukku, whatever food they make at home, high sugar, salty, French fries, potato wedges, Bing Chun or Chumbing, I don't know what the name is anyway. All of that high sugar and salt intake. So people are not aware. Sometimes when people who have this, suddenly when they what you call get a blackout, they fall, and sometimes if there is nobody to help, they will pass away. So now they have made a flexible electronics where they can paste it like a small sticker in their arm. Whenever the blood sugar level goes down, it will indicate digitally. Now blood sugar level, let's say your father is having blood sugar or mother is having or somebody is having. Some kids your age also have, They, they normally have a device, they prick it and they take the blood in the blood. I think, how many of you have seen a what do you call, glucometer? There you go. That means, everybody has somebody in the family. There. So they prick it and they check how much. Imagine nothing to prick, no blood taken. In your hand, like a digital meter, it's going to read. Clear? It will show when the blood sugar goes down. When the blood sugar is what? High. That kind of level of electronics is being made, and that's a collaborative effort between the physics department and also what? Medical faculty, which will help the patient more. Then the patient knows that he doesn't have to wait to go and take a what you call blood test to check if the blood sugar is low. That will what? Directly so. People who have pressure also, pressure indicators are there. There. So these kind of things actually helping what you call humans as a whole, but I think we should reduce our sugar intake and our salt intake. Easier said than done. Everybody loves to enjoy what a good ice cream. So therefore, easier said than done for Sri Lanka. So therefore, these kind of simulation studies are very important. I'll show you certain simulations which will be useful for you all to actually for example, now you all have learned about these things from O levels, huh? O levels, O levels. What have you learned in O levels? I don't know. But I learned some basic things in O levels. No? I have seen your science teacher teach mixtures and all. I have seen. Right. We'll start with something very basic with everybody can. You have loads of things, huh? Loads of simulation. We start with something basic for you to understand how. So, so here you go. These your what? Famous O-level equation. P equal IR. It's called what? Ohm's law. Now, these are your what? These are what? Battery. Very good. Identification info. What is this? Huh? Resistor. Very good. What are these small dot paths? Electron. So why do you have a resistor? Electrons are colliding with each other. There's a resistance to movement. Right. Now here I can control the voltage. There you go. 1 volt, but 1 volt voltage is 1. Now I'm going to change the resistance. Now look at this I and R. Huh? I'm going to reduce. So when you reduce the resistance, can you see? Less number of electrons, more current will pass through. Lesser the resistance, greater the current when the voltage is fixed. 1 volt. Now to tell this, your O-level served at dance and the Candian dance to tell this. Yes. This is now much more easier. You have simulations, so nicely show this. Clear? So these are your electrons, so you have a better idea now with the resistance reducer. Number of electrons in the circuit will also what reduce. When the number of electrons reduces, it's much more what easier to travel. Now, if I increase the resistance, can you see the current? Current will reduce. Yes. This is in milliampere. Large current. Less current. More crowded. Difficult to travel. That can be taught like this. And you will remember this much more better than what? Drawing on the board and doing whatever. Understood? Yes. Now also you can increase the voltage. When you increase the voltage, number of batteries increase. Okay. When number of batteries increase, more voltage is given. Now if you can find current voltage divided by resistance. Resistance is 1000. So here 4 divided by 1000. 4 volt divided by 1000 ohm, you get 4 milliampere. Then 4 divided by 1000 is 0.004 ampere. 3 decimal places. So 4 milli. That can be found by changing the resistance. You can see the electrons here will also what? So these are simulation mode learning. Yes. You can learn with different simulation. Different simulations are there. We'll show a few more. So I learned about that is one. Ohm's law is one. All right. Something very basic. In O levels, you all learn about density, all of that. Huh? There you go. So I take the fellow out. There. Now there is 100 liters of water here. Can you see? I marked 100 liter. So here, mass of the object, I can select the type of. We start with wood. 2 kilogram. Volume is 5. Volume is, if you want, you can make the volume smaller. But when you make the volume smaller, mass also will become small. Right? No? By mass and volume are connected to each other. Right. Now, when I put the block inside, now those days only your sir will be drawing, putting the block inside only. Now very one thing gone. Now why is it floating? Tell me that, Pilu. Why is it floating? Upthrust is there. That means weight is balanced by the upthrust. But something important, huh? Here, look. When I put it inside, the volume here also has increased. Earlier, how much of volume was there? 100, now became about 102. So the difference there is how much? 2 liters. That is called your displaced volume. Can you remember what you call Archimedes? Shouting Eureka, Eureka and running. You remember the running part? How? Now, that additional volume is called what? Displaced volume. The weight of the displaced volume is your upthrust. Understood? Then the weight of the displaced volume is your upthrust. Now, for example, that's wood, no? Let me change to styrofoam. What is styrofoam? Regiform. So, regiform, the mass is there, whatever. There, the displaced volume is lesser. And regiform will always float. Here, you put regiform inside, it will float. Small amount is submerged. Okay? Small amount is submerged. Here, ice. Ice means this ice scatter. Or other ice. Sri Lanka, we have other ice also. Here, 100 liters, that's ice. I think I'll make it 5 kg. 5. Okay. Now look. Still floating, huh? Submerged but floating. Small part on top. Icebergs not travel like this. Small part is on top. Hidden part is what? Very, very dark. Iceberg, Titanic. Jack and Rose. Right. Now, if you take a PVC, what is PVC? PVC tubes and all you have at home. That's made of material, no, that density is higher. The PVC density is given 1.44. The moment you put that in, it will sink. So in O levels, they teach you why the object sinks. Density of the object is greater than the density of water. If the density of the object is lesser than the density of water, it will what? Float. The densities are equal, it will fully submerge and float. The density is large, it will what? Sink. So here it's going to be larger, so it's going to sink. Let's say a brick. A brick density is large. So the moment I put the brick in, it will what? Sink. Right? Densities are large. Here submerged volume or displaced volume is also there. So these are for single objects. Now you can compare. You can compare. For example, I will take styrofoam one. I will take wood one. Here, make it 1 kilogram. 1 kilogram for both. Masses are same. Right. So we have wood and styrofoam. These styrofoam. So before I put it in, what do you all think? Who will sink? Who will float? Who will sink? Who will float? Both will. Both will float. Some people say both will sink. Let's see. Put this put. Put is floating. So both is sinking wrong. Huh? Put is floating. Here displays 1 liter. 1 liter display. Masses are same. Here 1 liter displays 1 kilogram. Whatever the object, if that mass is also same, the displaced volume will also be what? If I take this out, what? So in O levels you will learn, if the weight is the same, the displaced volume will also be what? Irrespective of the object. Now this is much more easy for you to remember. Both masses are same. Clear? Both masses are same. 1 kilogram, displaced volume 1 liter. 1 kilogram, displaced volume 1 liter. If I put both inside, displaced volume how much? 2 liter. Irrespective of the shape. If the mass is the same, the displaced volume is also what? This is not A-level work. I'm just showing O-level work. You know? The O-level work I'm showing, not A-level work. These are basic things you learn in density lesson. But now you can nicely compare and learn. Can you see? You can nicely what? Compare and learn. Now this comparing and learning is part of science. Always remember, comparing and learning is very important. That is only science. Now even for the ones who memorize this, now today you remember the picture. Wood, styrofoam. 1 kg, 1 kg. Displaced volume is going to be what? Whatever their shape, displaced volume is going to be what? Understood? Clear? So one more simulation and then we move on. So we'll be learning like this as well. So these days, what is the most famous simulation? These days, current affairs. Currently in the world, we are in war situation. Man-made war. Clear? So in man-made wars, people use weapons. Who makes weapons? People who have learned science. Okay. When Einstein was there in the Manhattan Project. What is the Manhattan Project? The Manhattan Project was the project that was made to build the atom bomb. Yeah. And because the Americans thought the Germans were building their own dirty bomb. The Germans under Hitler, they had their own scientists building their own. So the Americans, they wanted to build the bomb much more faster. That's how the world developed. Actually, the world developed very quickly because of the war. And therefore, what? The Manhattan Project, they were developing this. And they finally found a solution for it and they built it. Once they built it, they say, Einstein saw the destruction that can happen and he said the science should never be used like this. But it was too late. But he anyway helped to build it. After helping to build, I don't know now. Mara Vede, Mara Kesaka, you can't tell. Once you help to make, then the rest is history. There. So even though Einstein was the greatest mind, Einstein was one of the greatest minds to ever walk on planet Earth. He also was what you call part of the team that but made the first nuclear bomb that wiped up Hiroshima and Nagasaki. Yeah. That wiped off Hiroshima and Nagasaki. Yeah. Now, so therefore remember, whether you like it or not, that is what normally happens. First, I'll teach something much more better. Solar system. Now, all of us like how the sun moves, so on. Right. So, this is your planet. This is, let's say, a large mass. The larger mass is 10 times bigger than the small mass. Right? So, these are how the orbits are actually are. The planet is rotating around the larger mass. The planet is rotating around the larger mass. The larger mass also is rotating around itself. Now in class, people can't be drawing this and so now you remember it. You've seen it 7th? Yes, you've seen it 7th. Now you answer me. If this was Earth, this was Sun, he is going in a full circle around it. It's a circle. How long does the Earth take to go around the Sun? Yeah, 300. So let's say 365. You tell me now, how long does it take for the Sun to go around itself? How long does it take for the Sun to go around itself? Eh? How long? Okay, help you all with all in canteen or sometimes you can't see the sun. I think that's the sun will rise from where? Sun will rise from where? Sun will rise from where? East. Sun will set at the. Then again it will happen when? Next day. So how many hours? 24 hours. Clear? Understood? Clear? But generally remember, that's what people think. Now you are rotating around the sun. We say 24 hours because the earth is rotating around itself, not the sun. Don't misunderstand that. Sun will take a different amount of time to go around itself. Clear? The earth will go around the sun. Also remember the earth is rotating around itself. That is not marked here. Time taken for the earth to rotate around itself is 24 hours. Clear? Sun is there, earth is rotating. So one side facing the sun, one side is what? Not facing the sun. So earth will take 24 hours to rotate around itself, not the sun. Sun will have a different periodic time. Understood? Clear? Clear? So remember, earth will take how much? 365 days, so many hours to rotate around the sun. Earth will rotate around itself is 24 hours. That is why we have a sunrise and a sunset, or a sunrise to a sunrise. We have a 24 hours. Because one location will face the sun, the other location is going to be dark. For example, when we are facing the sun, when we have a sunrise, In America, there's going to be a sunset because they are facing the opposite end of it. So for you to go one cycle, it's going to be what? 24 hours. So for the earth to rotate around itself, 24 hours. Earth to rotate around itself and go around the sun, how much? 365 days. Sun to rotate around itself, then there's a certain period of time which can be calculated. Yeah. And remember, even though we assume it's circular, it's not circular. Right. Now, it's okay. Look at this. Now the masses are 10 to the power 28 times. 25 are. Two bodies are there. Here, sun and planet. Here, sun, planet, moon, there are different selections to do. We'll take sun and planet. That is what we did earlier as well. Huh? That is what we did earlier as well. So for this planet to go around the sun, it will take how many years? Something like 2.8 years. For this planet to go around the sun, it will take what? Something like 2.8 years. Now look, sun, planet, moon. That's how the moon goes. Can you see? That's how the moon goes. Now, Ramadan and all, new moon, you have to see, no? That's how the moon is going. Oscillating. So, the sun is rotating around itself. The planet is rotating around the sun. The moon is rotating around what? The planet. While the planet is going. Understood? Clear? So that's the oscillation that is taking place. I'm sure none of you all thought that in this term. You all thought what? How do you all think? Earth is going around. Moon is going around the earth. While traveling only, this has to go. While going, if it's rotating and bearing, it will not know. Then it has to go like this. Without knocking. Understood? Otherwise, knock no. You're going this way. Yes. You're turning this way. Another fellow is turning around you. When you're going, that fellow will knock on you someday. So to stop knocking, you have to go what? Around like a screw around. That is the shape. Then what? Comet. Not commode, comet. Name me a comet. Famous one. Whose comet? Halley's comet. Halley's comet returns to the earth after how long? 70. No, not 70. 70 odd years. 72 years to be exact. Every 72 years only Halley's comet will pass the what do you call earth. So they say it's a rare occurrence. Once you have seen Halley's comet, again you might not see Halley's comet in your lifetime. In your lifetime again you will not see. Look below. So that's your planet. That's the sun or whatever. Halley's comet is given by number 3, the small green. It speeds up, huh? Near the sun, it speeds up. The comet speeds up. Far away, it slows down. And it makes sure it will never collide. So this is the path of the comet. That's the path of the planet. Sun is there. Okay. Then the dangerous one. Asteroid. Asteroids can collide with Earth, and these what we call doomsday. Loads of films also were made. Whenever there is an asteroid coming towards the Earth, Earth somehow finds a to save planet. NASA will somehow build somebody and send somebody on the asteroid, put a nuclear bomb on the asteroid will blast, and the two particles will what? Cross and not collide with the Earth. That's the end story. In between, there is a love story also going by. Right? The film, it should be like that, no man. Otherwise, can't. Yeah, people watch films to not get stressed, no. There should be enjoyment part as well, right? So now, these are asteroids. Can you see their pathways? Different colors are there. Sometimes they will speed up. They keep on rotating. Now look at this. The moment I change the mass, their pathways change. Huh? Can you see they collided? One is still coming. That they're there. Then I'll just go for one more binary star. These are binary stars. Stars which rotate around the sun in couples. Now, these are things that you will learn in A level, what you call gravitational theory. You will learn how these interactions take place. You will not learn much about the mathematics, in fact. Mathematics you learn when you go to university, if you do physics as a specialization. But you learn how these interactions are, you learn how to put calculation, you will learn how to send a rocket, the equations for the rocket to go out of space. There. All of that you will learn. You know, all of that you will learn. So these things, remember, are all connected to physics. They are all connected to physics. So these for planets in motion, planets in motion. Now, I told you, these days the world is famous for what? Missiles and ballistic missiles, and don't you know? Ah, you will learn about this in physics. You learn about this in physics. There is a mathematical connection to all of this. Now, here you go. These are 15 range. No air resistance. Let's say there's a pumpkin. Initial speed 15. No angle. Just keep it like that. And that was the projectile to shot the pumpkin. I can increase the speed. If I increase the speed, the range will what? Increase. Clear. Now, angle. Come down on it. Go on. Out of the screen. There. That is also gone. Speed is too much. Reduce the speed. One up. We have to hit that target. To hit that target means let me reduce the angle a bit. Okay. This is how they do. Target is there, you must shoot the fellow. Where? This fellow is not coming in, right? Hello. Ah. Can you see? Now if I reduce the angle a bit and then try it again, most probably it will strike. These are they do. Yeah, these are they exactly do. But you'll be learning the physics behind it. You'll be learning about the components of the vectors. For example, if I apply that, how the velocity is changed. There's a beauty in the story, but also there is a physics behind the story which you will learn in detail. That you will deconstruct. You will take that out. The story is very simple. There is a target. I must hit the target. Yeah. But then there is a physics behind it. That's the velocity component. Then what do you call acceleration component? If I try this again, let's erase everything. Let's say angle is 10. Let's say speed is 5. Let's say we want to hit this fellow. You might think if I hit straight like this, it might strike. Let's see. No, it won't. Gravity will bring it down. Maybe I target somewhere there, then most probably this fellow will get the shot. Okay. Almost there. Maybe I can break his legs. I don't know. Maybe. Okay. But here you learn about different what? Velocities. Now, if I put air resistance, I won't get the same path. It will even closer. Here. The path will change. Let's say 10 degrees. Correct. Exactly on the ferrule. But if I remove the air resistance and then 10 degrees, slightly in front of it. So therefore, remember, by changing the trajectory, if I put it up, it will go vertically up. 60 means like that. Reduce the speed. Speed is less. Right. I want to hit that target. Slightly increase the speed. Right. So there you go. When you play around with it, you understand that what do you call? Okay, there is a science behind it. We call it gamification. But also these velocity components, acceleration. If air resistance is there, it might not strike there. Let's see. Can you see? Outside, not bullseye. Because air resistance will make the path more what? Much more what? Lesser. When you're sports meet days, you throw the cricket ball. What you call primary. They won't give putt shot. No. Primary there to take the ball. The boys throwing. I don't know whether girls have throwing the cricket ball. But boys have something called throwing the cricket ball. How far you can throw the cricket ball. Okay. So there you have air resistance. So therefore, the actual path and the actual trajectory are different things. Without air resistance, further away. With air resistance, what lesser? So there will be effect. So all of that you will learn as part of your study when it comes to what A-level physics. Okay, no? So anyway, right. So what we have done today, 7 fundamental quantities, 2 supplementary quantities, You learn to convert degrees to radians, radians to degrees. You learn the relationship between S and theta, length and theta. Before I let you go, very small connection. We call this derived quantities. What do you mean by derived quantities? I can use the fundamental quantities to make new physical quantities. Those are called what? Derived quantities. Okay. Right, subtopic? Derived quantities. Derived quantities. That is small sentence. Physical quantities which can be made physical quantities which can be made by using fundamental quantities, by using fundamental quantities, by using fundamental quantities are known as derived quantities, are known as derived quantities, are known as derived quantities. Okay. Now what does the sentence say? I'm going to use fundamental quantities to make new physical quantities. Those are called what? Derived quantities. Look at these examples. Area. What is area? Length into breadth. That means you are multiplying two lengths. You are multiplying what? Two lengths. Length what is a fundamental quantity? Mass, length. Fundamental quantity. What are the units? Here meter, area is going to be how much? Meter square. Then you have volume. Volume is what? Length into breadth, another length, into height, another length. Technically, you are multiplying three lengths. Meter, what's your answer? Meter cube. Then you have three types of densities. You all only know one type. Linear density is mass divided by length. Now, mass is a fundamental quantity. Mass is a fundamental quantity. Length also is a fundamental quantity. Using fundamental quantities, I have made what? A derived quantity. Linear density is going to be what? A derived quantity. So here I can put kg m minus 1. This is new for you all. Huh? You have surface density. What is surface density? Mass divided by area. Mass is going to be fundamental kilogram. Area also I can make using fundamental meter squared. From this we get kg m minus 2. Kg m minus 2. Fifth one. This is what you all know. Volume density. Volume density is mass divided by volume. Mass is measured in kilogram. Volume is measured in cube. Take on top kg m minus 3. So what do you call this? Derived quantity. Yeah. So if I can use fundamental quantities to make new physical quantities, those are called what? Derived quantities. Yeah. That's right. Consider the following examples. Consider the following examples where the fundamental quantities are used, where the fundamental quantities are used to make new physical quantity. Fundamental quantities are used to make new physical quantities. New physical quantities. Which are known as derived quantity. Which are known as derived quantities. Where the fundamental quantities are used to make these quantities which are known as derived quantities. Okay, no? Write down. Area, 5 examples are given. So next week we'll continue and do more examples and then we do applications of dimensions and all. For now you can write these 5. Area, volume, linear density, surface density, volume density. So remember the Sunday class will be purely done on English, this medium. But then some of you all, some of you all want some help in the language, bilingual as well. That is done on a separate date. That will be done on Thursdays night. So some of you all who maybe understand Sinhalese well, you all want to get another additional help in Sinhalese. But of course on Thursday evenings, you all will be added to that pure online class, bilingual help. Where I'll be explaining in most probably Sinhalese for the ones, majority of them ask for help. Others, you all can join this and go because this class will be done purely only in what? If you all want any additional help, freely you all are added to the bilingual one. So you all can get some additional extra explanation in Sinhalese as well. There. So that will be done separately. I will not mix both. English medium class is done in English. But any language explanation, I will do it separately on Thursday night, 7:30, 10:30. Same lesson. In Sinhalese, I will explain. Okay, no? So not like other classes, I do this purely only English. But additional help in a separate time, I will do. Understood? Clear? Just like we have done in today's class, we didn't talk in other languages. Only in English. That's how it goes. But language help on Thursday nights, I will do. So I will be added to it. If you want, you can join. Anyone wants any special request can make to the office. Will be added to that so that you can join that class. Otherwise, no need. You can join. Same thing will be done. Okay then. I will see you all next Sunday. Next Sunday, 8 be sharp. Today we started at 8:20 because still some of you all were coming. 8 to 11 before results come. After results come, 8 to 12, there will be a break in the middle. Also remember, today chemistry class will be started at 12, 12 to 3. Minus will be doing the class. Good teacher. Produce a lot of results as well. So if you want, you can join and see. Next, bio class. Miss Zainab Shafi will be starting after Ramadan. That means 28th Saturday, if I'm not mistaken. More information, please get from the office. Mathematics class, so will be starting this week. I think tomorrow on Monday. That is also you can get information. All are paper marking teacher. Now, maths teacher is a paper marking teacher from girls' high school. So normally for maths and all, we normally say always try to go near paper marking teacher because they exactly know what you should know to score marks. You know? All information please get from the office. I'll see you all next week then. Morning 8. Okay then, take care. Get home safe. Online students also, any doubts you can ask. Your class will continue on Sunday at this time. Huh? Right. How to join the class from next week? The required things will be put in the channel. So you can follow the process and buy the thing through the website and join. Okay, no? Okay then, tell your friends as well. Anybody who could not join today, I'll put the recording as well. But next week, you'll have to join too. Okay? Right.